Alright guys, so today what we are going to be looking at is triangles. So we know so far we've looked at the measurement of interior angles, and we know that the sum of the interior angles was 180 degrees times n minus 2. We also know that since it's that using that formula, if we've got three sides, that we know that all interior angles of the triangle will add up to 180 degrees, no matter what the triangle is. So what we're going to be looking at today is how we can classify triangles, because looking just here, we can tell that all triangles that have three sides and three angles do not necessarily look the same. So we've got three ways that we can classify them if we're looking at their sides. If we're looking at their sides, the first way that we can do it is we can look at if all three of them are the same, we've got what's called an equilateral triangle. An equilateral triangle literally means that all three sides are equal. And that just means all sides are the same. Looking at another way, what about if two of the sides, so in this case, we've got two sides that are the same, but this side is different, where these ones are long and this one's short. This is an isosceles triangle. An isosceles triangle really just means that two of the sides are the same. The way I always remember this one, though, is SOS. Same, opposite, same. And that just means two of them are the same, one of them is not the same. Your third way that you can classify is if all three sides are a different length. If all three sides are a different length, this is called a scalene triangle. And a scalene triangle just means that no sides are the same. So that's one way that we can measure all of our triangles. The second way that we can look at our triangles is by the measurement of their angles. Now, with angles, we can measure them if it's got a right angle in anywhere. If any of the angles is a right angle, we call this a right triangle. And that just means that it has one 90-degree angle. The thing with this is, if this one is 90 degrees, these other two cannot be 90 degrees, since we know that its three angles has to equal 180 degrees. If this one is 90 degrees, the other ones cannot be anything close to 90. The next one is, if we notice that this is, remember our discussion earlier today, looking at this angle, it's an acute angle, and this one's an acute angle, and this one's an acute angle. This is an acute triangle. And an acute triangle just means that all three of the angles are acute. And then our final one is an obtuse triangle. And an obtuse triangle just means that one of the angles is an obtuse angle. And that just means it's greater than 90. Now, once again, if it's got an obtuse angle, these other two have to be an acute angle, because there's no way that you can have more than one obtuse angle, because the grand total has to be 180 degrees for the interior angles. And if one of them's already over 90, there's no way you can have another angle that's over 90 degrees in an obtuse angle. So an obtuse angle just means it has one angle that is an obtuse angle. Generally, we classify them by both. So looking at this first one, we can see that, okay, well, we've got one side that's the same, one that's opposite, and one that's the same. So this one would be called an isosceles triangle. And remember my little trick where I look at that SOS, same, opposite, same. That's an isosceles triangle. And then looking at it, I look at this one as, okay, that's less than 90. This one is less than 90, and this one is less than 90. So I know that this one is an acute angle. So when I classify this triangle, I would call it an isosceles acute triangle. Looking at this one now, I've got one, this side is different, and this side is different. And when you look at it in pictures, often you'll see it with these little tally marks. And the tally marks literally just mean this is one length, this is a second length, and this is the third length. So since all three sides are different, this is a scalene triangle. And looking at the angles, I see, okay, well, this is an acute angle. This right here is another acute angle, but this one, okay, well, 90 degrees would be up here, so this is definitely bigger than 90 degrees. So this would be considered an obtuse triangle. So when I was asking how would I categorize this triangle, I would call it a obtuse scalene or a scalene obtuse triangle. Just a couple more. Looking at this, now instead of doing dashes to kind of show you, I'm looking at measurements. So I'm looking here and I say, okay, 20 centimeters, 20 centimeters, and 20 centimeters. Well, since all three of them are 20 centimeters, they're all equal. So this is an equilateral triangle. And then looking at it, and now I'm giving, once again, we're going with measurements. Without the eyeball test, I can go, okay, well, this is 60, 60, and 60. In 60 degrees, they are all acute angles. So this is an equilateral acute triangle. And same with this one. Looking here, I see, okay, this is 35, 54, and 35. Well, 35, 54, and 35. So we've got two that are the same and one that's different. So that's an isosceles triangle. But I see that little box. That little box tells me right away, without anything else, ding, 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 it's a 90-degree angle. So that is a isosceles right triangle. So I'm going to leave these last two up for you. I'd like you guys to go ahead and see, well, these last ones actually I'm going to go ahead and just go over them. And once again, I'm coming back into our idea that the sum of the interior angles equals 180 times n minus 2. Well, I know that 180 and then 3 minus 2 is 1, so that would equal the 180 degrees. And so 60, 60, and 60, there's my 180 degrees. On this one, okay, I know 60 and 20 is 185. Or 60 and 20 is 85. And then 180 minus 85 is going to be 95 degrees. So this is the last one that I'm going to have you guys practice with. I feel like you guys would do a pretty good job. I'd like you to not only identify this by the length of its sides and its angles, but I'd also like you to tell me what is the measurement of this last one, knowing that all triangles need to have 180 degrees. Have a great night.